Okay, stepping into the next chapter, we're going to kind of combine chapters 2 and 4 together. So, starting with chapters 2 and 4, we're going to get, or 2 and 3, we're going to get into some writing proofs, which is just kind of step-by-step leading us through a problem. So what we have here is a bunch of properties that we're going to use in our proofs of reasons why we can do things. So the first four up here, addition, subtraction, multiplication, division, are just what we do when we're solving equations. So adding, subtracting, multiplying, dividing a number to both sides of an equation is a legal move. The next one that we have here, the reflexive property, seems kind of silly. It's just saying that something is equal to itself. What we'll do is, the way that we'll use that is we will say that line segments are equal to itself. So like something like AB is equal to AB. It's the same segment, and so when we're proving that a shape that has AB in both of them, we're going to say that it's equal to itself. The transitive property and substitution are fairly similar. So with the transitive property, we're given kind of two statements. We're given that A is equal to B and B is equal to C. B is in common between these, and so if I know that A and B are the same thing, and then B and C are the same thing, my final conclusion can be that A and C are going to be the same thing as well. That should just kind of logically make sense, that if A and B are the same thing and B and C are the same thing, that A and C have to be the same thing as well. Substitution property, just whenever you say that two things are equal to each other, so A and B are equal to each other, that wherever I see a B, I can replace with it an A or vice versa. So if I see an A and I know that A and B are the same thing, wherever I see an A, I can plug in a B. And then the next one, distributive property, that's stuff that you did in algebra and that we've done in this class. Just distributing, taking the thing on the outside and multiplying by the two things on the inside. So again, the way that we're going to use this and work this is this is kind of a two-column proof. So on the one side, I'm going to have my my reasons. So I've got my statements on one side, and then my reasons on the other side. It's kind of divided into two columns here. And so when I'm doing this, what I want to do is, so I'm going to solve the equation 2x minus 4 is equal to 6 and justify each step with a reason. So the very first step that we're always going to include in here is going to be my what I'm given. So 2x minus 4 is equal to 6. That is what I'm given in my problem. The second step, so again, when I'm solving my equation, the very first thing that I'm going to do in this problem is I'm going to add the 4 to the other side. So the next step is 2x is equal to 10. And so this second step is going to be how I got from this step down to this step. So the way I got from the first step to the second step is I added the 4 to the other side. So this is going to be addition property. The third step is then going to be, again, if I'm solving an equation, I would divide both sides by 2, and so I would get x is equal to 5. And so my third step, again, how I got from the second step to the third step, is going to be division property. And there we go. That's all I have to do. Again, it's just justifying how I got from the previous step to the next step. With the second one, again, I want to do the same thing. So I'm going to have my statements. Along with my reasons. So again, the very first thing that I'm going to do is write down what I'm given. So angle 1 and angle 2 are a linear pair. And then I also have that angle 1 is equal to 2x plus 30. and angle 2 is equal to x. Again, that's all given information. So again, what I want to do is I want to solve the equation. I want to figure out what x is equal to. And so what I'm going to do with my second step is I want to write an equation based on the given information. So again, whenever I see that word linear pair, I know that linear pair means it's 180 degrees. And so I want to start with my letters. So I'm going to go angle 1 plus angle 2 is equal to 180. And again, my reason is going to be linear pair is equal to 180. Another thing that I could write in there would be a definition of a linear pair, because linear pair means that they're equal to 180. With my third step then, again, once I figure out what my equation is, then I'm going to go ahead and plug in my values. So I'm going to plug in 2x plus 30 plus x is equal to 180. Again, all I did there was just plug in values, and so when I'm plugging stuff in, that's just a substitution step. With my fourth step, again, just like if I were solving an equation, I would combine my like terms together. So I get 3x plus 30 is equal to 180. Two different ways we could write this. We could either write combine like terms, or if you wanted, you could put simplify. Then I'm just solving my equation just like we did in the previous problem, so I'm going to subtract the 30 to the other side. Get 3x is equal to 180. Oops. Forgot to subtract it. 3x is equal to 150. There we go. So again, that would be subtraction property. Just be careful, make sure we write subtraction, so we don't think that we're accidentally substituting. So be careful about your abbreviations. Then divide both sides. So x is equal to 50. And again, I got there by division property. Again, same thing with this one. So I'm given that AB bisects angle RAN. So again, I want to start off with my statements and reasons. So the first thing is what I'm given, which is that AB bisects angle RAN. My given. So again, what I know, if I'm given that AB bisects angle RAN, what I need to know is that the two angles are going to be equal to each other. So RAB and NAB are going to be equal to each other. So angle RAB is equal to angle NAB. So angle bisector makes two equal angles. Again, another thing that you put is definition of an angle bisector, because that means that it cuts it into two equal angles. Once I'm there, then I can go ahead and substitute in my values. So I know that angle RAB is x, angle NAB is 2x minus 75.
No, we had a delay until last.
So again, that third step, it's going to be a substitution step, because I just plugged in the values. Step number 4, again, I can subtract the 2x over to the other side, so I get negative 1x is equal to negative 75. Again, when I did that, I just subtracted the 2x over here. That's how I got the negative 1x. Again, that was a subtraction property. My fifth step, then I went ahead and divided both sides by negative 1, so x is equal to 75. That would be a division property. There we go. With the last one, again, this is just going to be slightly different because we're trying to prove, so we're given that km is equal to 35. What we want to prove is that kl is equal to 15. So when we're done, we don't just want to say x is equal to this. We want to say that kl is equal to 15. So just one additional step that we have. So with my first step, I'm still going km is equal to 35. That's my given. My second step, again, just given the picture, I'm not given that anything's a midpoint, so when I'm looking at it, I'm given two pieces in the entire. So again, I want to say that KL plus LM is equal to KM. And that would be the segment addition postulate. My third step, again, will be my substitution step, plugging stuff in. So 2x minus 5 plus 2x is equal to 35, which is the entire thing, which is a substitution step. Fourth is going to be my combined like terms. 4x minus 5 is equal to 35. Or simplify if you wanted. My fifth step is going to add the 5 to the other side to get 4x is equal to 40. Oops. Which is addition property. My sixth step is division. X is equal to 10. Division property. So again, I don't want to stop there. What I want to do is I want to prove that KL is equal to 15. So once I'm here, what I want to do is I want to take that x and I want to plug it back into the original. So if I want to prove that KL is 15, I want to grab the 10 and I want to plug it in for KL. So again, I'm going to have 2 times 10 minus 5 is equal to KL. Again, that's a substitution. Then I can go ahead and simplify this. 2 times 10 gives me 20. 20 minus 5 gives me 15 is equal to KL. Again, that's a combine like terms or simplify.